Hello everyone, welcome to our channel. Here, we frequently discuss various technical topics to help you better understand and apply them. Today, our topic is path manipulation, which you might also see referred to as path traversal on the OWASP website, or sometimes as directory traversal on other sites. Path manipulation is a common security issue that involves how paths are handled within the file system. If not handled correctly, it can lead to unauthorized file access and may even allow attackers to execute arbitrary code. In this video, we'll delve deep into path manipulation, covering what it is, how it works, and how you can protect your system from its effects. We'll start with the basic concepts and gradually move on to more complex topics. Whether you're a beginner or an experienced expert, I believe you'll find valuable information here. Now, let's begin our journey and explore the world of path manipulation together. If you enjoyed this video, please remember to hit the like button below and subscribe to our channel so you won't miss any of our updates. Now, let's get started. Before we dive into path manipulation, let me introduce the tools we'll be using today. First, our programming language of choice is Java. Java is an extremely popular programming language known for its cross-platform capabilities, object-oriented features, and rich API, making it the ideal choice for our study. We'll be using IntelliJ as our Integrated Development Environment, or IDE. IntelliJ is a powerful Java development tool that offers many convenient features such as code completion, syntax highlighting, and error checking, which will make our development process much smoother. Next, to identify vulnerabilities, we'll use Fortify for vulnerability scanning. Fortify is a robust security tool that can help us pinpoint potential security vulnerabilities in our code and provide solutions to address them. In this video, we will explore how hackers use path manipulation techniques to access files and how we can modify our code to prevent such attacks. We will demonstrate these concepts through practical examples, helping you better understand and apply them. Now let's move on to the main content of today's video. The program we are demonstrating is called IWA, short for Insecure Web App, provided by Fortify. This is a typical web application, similar to those we frequently encounter in the real world. First, let's look at the results from Fortify's scan. The FPR file we have prepared in advance records all the security vulnerabilities in the program. In this FPR file, we found 11 path manipulation vulnerabilities. Today, we will be fixing one of those vulnerabilities to make the program more secure. Fortify indicates that the sink is located at line 56 in file system storage service.java. Let's go to this location in the IDE. I have added some logs to the original code to show us the file paths. This will help us understand how hackers can use our program to save files to unexpected locations. Now, let's run the program and observe the behavior of this vulnerability in action. Once the browser is open, I'll guide you to the screen where the vulnerability is located. I will log in. It is not necessary to enter OTP. And click on Upload XML files on the left. Then, we see an interface on the lower right side of the web page, which is where this vulnerability is located. Let's first try the normal operation flow, modify the XML content in the text box, and before pressing the Save button, clear the IDE log so we don't have to filter out the necessary information. Then, return to the browser, press the Save button, and go back to the IDE to check the log. In the log, we find the file storage location and copy this path. Next, I open File Explorer and find the file. I'll switch back to the browser. The interface doesn't provide an option to modify the file name. Then I'll switch back to File Explorer and open the XML file. As you can see, this is the XML content we just entered in the browser. Some might say that you can't change the file name in the browser, so there shouldn't be a path manipulation issue, but let's look at the next test. The IWA program requires multiple HTTP requests to execute an XML update, so I wrote a program called http_client.exe to execute these requests step by step. First, I'll run a normal test, which won't cause path manipulation. Before running the program, I'll clear the id log, then run the program. We can see that this HTTP body didn't cause path manipulation. And in the id log, we see the file name didn't change, only the XML content was modified. We used Notepad++ to confirm the file content was changed. But what if we run a test that causes path manipulation? We'll clear the log, then run http_client.exe with parameter 1. This time, we can see that the file name was modified, but the content remained unchanged. Back in the IDE log, we can see that the file name was altered using the .. changing the file location. Because the triple .. were used, it has moved back to the root directory. We find the root directory and see that the file's timestamp is recent. Next, let's see how to fix this vulnerability. We'll comment out the code at line 56, then uncomment the code below. The new code restricts file names to letters and numbers only, preventing path manipulation. I'll run the Fortify skin again. First, I want to keep the original FPR, so I'll rename it. Since IWA is a Maven project, I'll use the Fortify Maven plugin to scan it. The process is similar to using Source Analyzer, X. First, clean to clear previous skin data. Then translate to generate the NST file. And finally scan to produce the FPR. This time, we see a new FPR file in the file manager. I open the FPR. And from the original 11 path manipulation vulnerabilities, only 10 remain. The vulnerability we fixed is no longer listed, proving our fix was successful. Now, let's take a look at how the alpha number function is written. Since it only passes the scan, I'm not sure if the code truly prevents path manipulation, so we'll run the modified program to verify. After completing all steps, we'll clear the log. Run http_client.exe with parameter 1 and check the console to see if there are issues. Switching to the IDE log, we see the program produced an exception. Finally, in the root directory of the C drive, we see the file timestamp hasn't changed, so the file wasn't saved at all. Thank you for watching our deep dive into path manipulation vulnerabilities using Fortify's IWA. In this video, we introduced how to identify, test, and ultimately fix a critical path manipulation issue. We demonstrated the importance of thorough testing and how attackers can exploit these vulnerabilities to manipulate file paths and store files in unintended locations. Path manipulation vulnerabilities are a serious security concern. Attackers can exploit these vulnerabilities to access, modify, or even delete any files in the system, compromising the system's integrity and confidentiality. Therefore, it is crucial to identify and fix these vulnerabilities promptly. We started by examining the original vulnerability in file system storage service.java, showing how to log and trace file paths, and perform tests with both normal and malicious inputs to illustrate the exploit. By modifying the code and rescanning with Fortify, we confirmed that our fix effectively mitigated the vulnerability. Addressing such vulnerabilities involves strictly validating and verifying user inputs, using secure APIs for file operations, and employing normalization techniques. Find an approach that best suits your program's needs. Remember, security is an ongoing process, It's not just about fixing one issue, but continuously monitoring, testing, and improving your code to guard against potential threats. We hope this video has been helpful and provided you with valuable insights into handling path manipulation vulnerabilities. If you found this video helpful, please like and subscribe to our channel for more content on software security. Feel free to leave any questions or comments below. We'd love to hear your feedback and discuss any topics you'd like us to cover in future videos. Stay secure, and see you in the next video.